Hi Pirates, we have made it to another fan favorite in the world of derivative applications. This one sounds super fancy, but I promise you we already know how to do it. This lesson is called linearization, which is also sometimes referred to as linear approximation, which really at the end of the day just means you are approximating with the tangent line. So let's kind of recall, first of all, what did we need for a tangent line? We needed a point. In this case, I'm going to call that point A, f of A. We also needed a slope. Where did the slope come from? The derivative. When all else fails, I should take a derivative. So then I told you, well, let's just plug it into point-slope form. Y minus y equals m times x minus x. All that this section literally does is solve for y, and then they call it L of x. OMG, it's the tangent line in separate form. So the linearization is nothing more than the tangent line solved for y. In BC Calc, you're going to get to do polynomial approximations. Get excited. And that's going to be where you get to find a couple more derivatives along the way for a better approximation. So there's basically three things you might be asked to do with this linearization. The first thing is to just find it. So you would be given a function and they would tell you what neighborhood to approximate. So let's first go back to Algebra 2, Algebra 1. Square root of x looks like a shooting star. Yes, it does. 1, 2, 3, 4. Points come from the original. So square root of 4 is 2. I'm looking to find the equation of this tangent line. Now please know that this linear approximation is only good in the neighborhood of 4. If I were to ask you something about 17, not such a good approximation because it would be too far from the function. So in this neck of the woods, it's a pretty good approximation. When all else fails, I should probably find a derivative. Remember, this is really like x to the 1/2. So 1/2 x to the negative 1/2. And if I plug in 4, I get 1 over 2 square root of 4, which is 1/4. So my linearization is going to be 1/4 x minus 4. Now really, if it was on the left, it would be minus 2, but when I add it to the right, it's plus 2. Okay, so the first thing I want to do is find the linear approximation. Now I want to use it. So really, this is a no calculator question. Before the days of TikTok and Snapchat and Instagram, they would actually do math without a calculator, shocking but true, to approximate square roots. This is how you approximate square roots without a calculator. So in this case, I want to kind of figure out, well, who's my x value? X was chilling under the square root, so this right here is really code for x equals 4.1. F of 4.1 would be about L of 4.1. This is an approximation, which is exactly equal to what I get when I plug it in right here. I have 1/4, 4.1 minus 4. I didn't get too far away from the neighborhood. You might recall this is 0.1 or 1/10. So I have 1/40 plus 2, which if I add that together, this would be 80 over 81/40. Now, just for kicks and giggles, and this is where the real fun in this whole activity happens, let's see how close we are. Okay, if you were watching this on a board, you would be mind blown right now. I'm sorry that I can't do that for you. So 81/4 is going to be 2.025. Okay, just for kicks and giggles, let's look on our calculator, oh, just kidding, and figure out what the square root of 4.1 would be. Okay, so I'm going to type it in just to a regular calculator. I know it's a no calculator question, but just for fun. OMG, friends. 2.0248. You just figured out the square root without a calculator. Last but not least, I know you're excited, I am too. Last but not least, we want to decide over or underestimate. Now, you can't just say it's bigger because it's bigger, although sometimes we like to do that. We need a little more mathy reason to feel that way. So let's go back and look at this picture. I think you would agree, hopefully, that 2.025 is greater than the actual value. So it is an overestimate. But what about this graph makes the tangent line be above it? Well, it has to do with the fact that f of x was concave down. So if f of x is concave down like a frown, your tangent line will be over it. Side note, let's just kind of think about that. If I had something that was concave up like a cup, my tangent line would be an underestimate because it's falling below the graph. Have fun with linearization!